Hello everyone, and welcome back. Today we are going to explore in detail one of the most important laws of physics that forms the foundation of modern technology, Ohm's law. If you've ever wondered how your phone's battery works or how electronic circuits are designed, then this session is extremely important for you. First, let's look at a simple circuit setup shown on the initial slides. It consists of a battery, which acts as the power source, a switch used to turn the circuit on and off, and a light bulb that acts as the load. When we turn the switch on, the bulb lights up. But the real question is, why do we need Ohm's law? In reality, Ohm's law helps us understand how changing the battery voltage affects the brightness of the bulb. It allows us to understand the mathematical relationship between voltage, current, and resistance. Now, let's talk about the three most important quantities. The first one is electric current. In this slide, we can see that current is actually the flow of electric charges moving through the circuit. The second important quantity is voltage. Voltage can be thought of as electrical pressure that pushes current through the circuit. The third quantity is resistance. Resistance is the opposition in the path of current that controls how much current can flow. All three of these quantities are closely related to each other. Now, let's come to the actual definition of Ohm's law. This law states that the current flowing through a conductor is directly proportional to the voltage applied across it, provided that temperature and other physical conditions remain constant. Mathematically, it is written as V equals IR. This means that if resistance remains constant, doubling the voltage will also double the current. To understand this concept better, let's look at the VI graph. In this slide, you can see that the graph forms a perfectly straight line. When the resistance is kept at 2 ohms and the voltage is increased from 5 volts to 10 volts and then to 15 volts, the current also increases in the same proportion. This straight line graph is clear evidence that voltage and current are directly proportional. Now let's move on to some practical calculations that will be useful both in exams and real-life applications. We are given a circuit with a 12 volts battery. Part A, we are asked to find the current when the total resistance is 40 kilo ohms. Using the formula V equals IR, we can write I equals V divided by R. When we divide 12 volts by 40 kilo ohms, we get a current value of 0.3 milliamperes. Part. In this part, we are asked to find the voltage versus across a 6 k-omega resistor, while the current is already given as 0.6 milliamperes. Using the same formula, again V equals I R dot, when we multiply 0.6 milliamperes by 6 kilo ohms, the result comes out to be 3.6 volts. So friends, this was a detailed overview of Ohm's law. Always remember that this law is valid only when the temperature remains constant. I hope this topic is now clear and easy to understand for you. If you have any questions, feel free to ask them in the comments section below. Don't forget to share this video. See you in the next session.